In this paper, we present a system designed to mimic the design workflow used by color stylists. Color stylists often have a creative background in fields such as fashion design, interior design, or the traditional arts, and frequently use tools such as a mood board, shown here, as well as concept sketches, either hand-drawn or created in Photoshop. First, we introduce a simplified BRDF model based on color design terms well known in the industry. This model's primary components are the face, or near-specular color, flop, or off-specular color, and travel, or color shift. In addition, a final gloss term is added to represent the strength of the specular highlight. For rendering purposes, these terms combine together to create a second-degree polynomial, where the x-axis is the aspecular angle and the y-axis is the color in LAB space. We demonstrate the usefulness of this new model by creating 3 new color design systems. The first is a virtual mood board. A mood board is a collection of colors and materials that designers use to inspire and guide the process of designing new colors. Our virtual mood board follows this concept by allowing an artist to put together a collection of digital images and artwork, and rearrange or resize them as desired. In addition, our virtual mood board allows an artist to use these gathered pictures to design new colors. This is achieved by utilizing the face and flop color model. Eyedroppers representing the face and flop components can be placed on the mood board, and a newly designed color is generated in real time. This allows an artist to easily navigate through source material and rapidly design new and interesting color themes. The second design system enables in-context tweaking. Artists often want to make minor adjustments to a color design. The ImageBased BRDF tweaker is a color design system for tweaking color and appearance directly on an arbitrary 3D object. Using simple point-based lighting, we create a correspondence from ImageBased to the BRDF of the color design. The BRDF is indexed using a specular angle, which is encoded in an off-screen buffer. Another buffer encodes the reflected view vector. This information is used to create a draggable color adjustment widget that is context sensitive. As the widget is moved across the surface of the object, the aspecular angle under the crosshair is retrieved from the off-screen buffer. The BRDF is evaluated at that aspecular angle, and some basic color variations are computed. Surrounding the crosshair are buttons that show these variations. When one of these buttons is pressed, the BRDF is tweaked to reflect the variation at that angle. When the crosshair is dragged off the object, a different display is enabled. This display visualizes the aspecular angle like a topographic map with contour lines. In this mode, the artist can drag the dashed contour line, representing travel, to adjust the rate of change between face and flop. Dragging the edge of the checkered circle, representing the specular highlight, will adjust the levels of gloss, affecting the size of the highlight. In this display, the artist can also move the light by clicking and dragging the interior of the specular highlight. As the artist drags the circle across the object, the system sets the new direction of the light by sampling the second off-screen buffer encoding reflected viewing angle. The final design system fits a BRDF to concept art created by the artist. Here, the artist starts from a rendering as a base to develop their concept. The rendering is loaded into Photoshop, and the artist freely paints to create the desired surface appearance. Working from a basic understanding of the BRDF, various tools are used to simulate the travel, gloss, and other appearance properties. Our system uses the resulting concept sketch and computes a least squares fit of the BRDF, aided by the lighting and geometry information from the original rendering. Any adjustment made in Photoshop can be synced back to the original rendering by simply saving the changes. A new BRDF is computed in less than a second. In this example, the artist is tracing over a printout of a rendered Porsche. The artist fills in this outline with a quick color sketch. The final sketch is scanned and placed over the original rendering using Photoshop. We then load this sketch into the BRDF fitting routine, which generates a new BRDF based on this artwork.